Welcome to all. I am Assistant Professor Kute Akshada from SND Engineering and Research Center Evla. Welcome to online lecture series. Today's topic is instrumentation of infrared spectroscopy. Infrared spectroscopy. IR deals with the interaction of infrared radiation with matter. The infrared spectrum of compound can provide important information about its chemical nature and molecular structure. Most commonly, the spectrum is obtained by measuring the absorption of infrared radiation, although infrared emission and reflection are also used. Widely applied in the analysis of organic materials, also useful for polyatomic inorganic molecules and for organometallic compounds. Infrared region. Near infrared or overtone 1.2 to 2.5 micrometer. Mid infrared or vibration 2.5 to 25 micrometer. Far infrared or rotation 25 to 400 micrometer. These are the regions of IR infrared spectrum. Instrumentation. Source, sample, monochromator, detector and radar. Nearest Glower, incandescent wire source, HGR, grating filter, thermal detector, thermocouple, thermopile, thermistor, bolometer, polyelectric detector and recorder. Source of radiation. The main source of radiation in mid-infrared region are obtained from a nichrome wire nearest Glower. When electrically heated up to 2000 degrees Celsius, they produce mid-infrared radiations. Be continuous over the wavelength range used. Cover a wide wavelength range. Be constant over long periods of time. The nearest Glower consists of cylindrical hollow rod or tube having a diameter of 1 to 2 mm and length of 30 mm. Sealed by a platinum leads to the ends of permit electrical connection. It composed of a mixture of rare earth oxide such as zirconium oxide or yttrium oxide and thoria. They electrically heated to about 2000 degrees Celsius. It provides maximum radiation about 7100 centimeter inverse 1.4 micrometer. Its lifetime depends on the operating temperature and the care taken in handling it. These are the diagram. Second, monochromator. In monochromators, first is prism. Prism used as a dispersive element constructed of various metal halide salts. Sodium chloride is most commonly prism salt used. These salts are subjected to mechanical and thermal instability of water solubility. Protection against damage must be continuously exercised. Second, grating. Gratings are nothing but the rulings made on some materials like glass, quartz or alkyl halides, depending upon the instrument. The mechanism is that diffraction produces reinforcement. The rays which are incident upon the gratings get reinforced with the reflected rays. These are the light of gratings. Advantages over prism. Made with materials like aluminium which are not attacked by moisture. Used over considerable wavelength range. Third, detectors. The detectors can be classified into three categories: thermal detectors, pyroelectrical detectors, and photoconducting detectors. First, thermal detectors. These are made from metals like BISB or semiconductor alloys as a thin film on support material. This material is kept in evacuated chamber. The incident radiation is absorbed by blackening blackened junction of the two metals. This gives rise an EMF in proportion of intensity of radiation. Their responses depend on the heating effect of radiation. Second is pyroelectrical detectors. The ferroelectric material produces polarization in it. When an IR radiation falls on it, this produces an electrical signal which varies with the intensity of IR. These detectors are now more commonly used. Pyroelectric effect depends on the rate of change of detector temperature rather than the temperature itself. Photoconducting detectors. Photoconducting detectors when infrared radiation falls on a photosensitive material. In vacuated tube, the conductance increases in proportion of intensity of radiation. This detector is highly sensitive but works only at room temperature. It is a most sensitive. Next, thermocouple. A thermocouple is made by welding together at each end two wires made from different metals. If one welded joint becomes hotter than the other joint, a small electrical potential develops between the joints. This is welded junction, metal welded junction. In infrared spectroscopy, the cold junction is carefully screened in a protective box and kept at a constant temperature. The hot junction is exposed to the IR radiation which increases the temperature of the junction. The potential difference generated in the wires is a function of the temperature difference between the junctions and therefore of the intensity of infrared radiation falling on the hot junction. Response time is 60 meter per second. To enhance sensitivity, several thermocouples connected in series are called as thermopile. To enhance sensitivity, several thermocouples connected in series are called as These are the diagrams of the cross-sectional sketch of the thermopile. Thermistors. Thermistors made of fused mixture of metal oxides. As the temperature of mixture increases, its electrical resistance decreases. Response time is very slow. Thank you.